Hello class, today we're going to take a look at how to factor special polynomials. And the first one we're going to look at is called the difference of two squares. The difference of two squares. Now we looked at difference of two squares when we learned how to expand and FOIL. Now we're going to go backwards. And let's say, for example, maybe I can get focused here. There we go. Let's say, for example, I had x squared minus 25, okay? Well, if you notice, the reason it's called the difference of two squares, we have a difference, a subtracting of two terms. Both are perfect squares. In other words, I can take the square root of both of those and have a nice square root. All right, so the question is, how does this factor? Well, if you want to do it the long way, we can add a zero term for the linear term. Put a 0x, right? These are the same thing. And we can use our reverse FOIL technique. If you forgot that, you want to take your constant number, ignore the sign, and list all the factors of that 25. In this case, it's 1 and 25, 5 and 5. Find the pair that either add or subtract to this middle coefficient, this linear coefficient. Well, 5 plus 5 is 10. That doesn't work, but 5 minus 5 is 0. That does work. So if we reverse FOIL, remember, we want to find two things that multiply to x squared. Well, the only thing that can happen is that, assuming both factors have an x in it. And we just found the pair that add or subtract to 0, right? So if I FOIL this, notice that the product of the last terms has to be negative, which means one of the signs is positive and the other one's negative. If I FOIL and check it, I get x times x. That's definitely x squared. Outside, I get negative 5x. Inside, I get positive 5x. That sum is 0. And then 5 times negative 5 is negative 25. So that works. Okay, so the question is, how can we go a direct route? How can we go from x squared minus 25 directly to this? Okay, well, there's patterns. You could sit there and put a 0x term in there all day long. That's fine. But if you remember this rule, if you have some term that's squared minus another term that's squared, it's always going to factor as a plus b times the quantity of a minus b, just like we saw with this example. Okay, it's always going to have that same pattern. So this is called the difference of two squares. So here's another example. What if I had 25y squared, let's say minus 9, and I want to factor this? Well, if we follow this pattern, if we can take, notice we start with a squared. So if we got to take the square root of this to find a, square root of 25 is 5. The square root of y squared is just y. So if you look at this, I need an a here and an a here, so that's 5y and 5y. And then if we take the square root of 9, that'll be our b value. I think we all agree the square root of 9 is 3. And if we follow the patterns, 1 plus and 1 minus. And if you FOIL this out, you will end up with 25y squared minus 9. So these are the two factors of this polynomial. Okay. One last example quick. Let's say we had x squared minus 100. Okay, well, hopefully now you see the pattern. The square root of x squared is x. Square root of 100 is 10. One of the factors is adding, one of them subtracting. Okay, so that's called the difference of two squares. So that's one shortcut you may use. I'm going to show you one more. And we did cover this when we when we expanded and learned how to FOIL. We learned the shortcuts. Now this one's not necessarily a shortcut unless you recognize it. So I guess it's just more or less, for me, it's always been a way to check. Let's say, for example, I have this polynomial, x squared plus 10x plus 25. Okay? X squared plus 10x plus 25. Well, going back to the algebra tiles we worked with, it turns out that if we have an x and 5 units, these are all 1, this represents x plus 5. And if we have the same dimension on top, and x with 5 of these little ones, 5 units, okay, this represents x plus 5, and you know the routine. Find the area, x plus 5 times x plus 5. I think you're going to find that we get 1x squared, which represents this. We get 10 x's. We get 5 on the side of the big x squared, and then we get 5 x's below. Alright, and then, so these are all x's, so that's 10x. And then, I'm not going to waste the time, but you'd have 25 little units in the corner. I guess I did take the time. So, what I'm getting at is, if you recognize that this is a perfect square trinomial, which this is the name of, perfect square trinomial, why is it called a perfect square? Well, look at the picture here. This makes a perfect square when you multiply the factors. Anyway, if you recognize that that's the case, the factors are x plus 5 and x plus 5. I kind of gave that to you. Now, most often we'll write this as the quantity of x plus 5 squared because there's two of the same factor. So the question is, how can we go directly here without drawing a picture and all that stuff? Okay, so I'm going to tell you straight up honest. Unless you're looking for it, you probably won't notice it. But if you recognize that this, well, let me write the rule out and then I'll explain. So here's the rule for perfect square trinomials. So if you have x squared plus 2, let me use a and b instead. If you have a squared plus 2ab plus b squared, okay, that will always factor as the quantity of a plus b quantity squared. And that's just what we did. So here's the kicker though. I mean, you have to be able to recognize that x is your a. You have to recognize that the square root of 25, which is 5, is your b. And this middle term is x times 5, 5x, and that's doubled. Now if you do that, if you can recognize that, more power to you. Use the shortcut. I'm just going to be straight up honest. Just reverse FOIL this thing. If you have x squared plus 10x plus 25, if you can visualize this, awesome, then you can use the shortcut, but otherwise just reverse FOIL it. So take your constant 25, list out the factors of 25, which pair add or subtract to 10. I think you all agree it's 5 and 5, and we know that if we FOIL, reverse FOIL, if those two signs are plus, those are two plus signs. X has to go here and here. 5 goes there and there. Check it, FOIL it. You're going to get x squared plus 10x plus 25. This is equal to the quantity of, x plus 5 squared, because there's two of them. So these are the two factors of this polynomial. Okay, and we would write it like that. Okay. This also works if this is subtraction. So if you have a squared minus 2ab plus b squared, this is going to equal the quantity of a minus b squared. So that's also a rule. So for example, if you have x squared minus 22x plus 121, let's say. So again, just reverse FOIL this thing. 121 is a perfect square, right? So you have 1 and 121, 11 and 11. Which pair add or subtract to 22? Okay, don't just, when I say that, I'm ignoring the signs. Pretend they're all positive. It's going to be 11 and 11. So x times x is x squared. 11 plus 11 is 22. So those are the two factors we want to use. And then when you do FOIL, when you multiply last, it multiplies to a positive, but the sum is negative. So that tells us these two have to be negative. And we will get the quantity of x minus 11 squared. Okay, so that's called a perfect square trinomial. Not really a shortcut, but it's a recognition thing. If you do recognize it, saves some time. The next video I'll show you how to simplify the sum of cubes and the difference of cubes. Adios.